Welcome to the channel. This is engineering tutorials, and today we're going to follow a worked example on gas turbines. And the questions I've written for you is a question that you'll find in your final exams as you finish up your diploma classes. But the question says a gas turbine unit takes in 17 degrees and 1.01 bar and a pressure ratio of 8:1. The compressor is driven by the HP turbine and low pressure turbine driven by the power shaft. This is isentropic efficiency of the compressor, the low power turbine and the high power turbine is 0.8, 0.85 and 0.83 respectively. Calculate the temperature and the pressure of the gas entering the power turbine and the net power developed per unit mass flow rate and the cycle efficiency. The maximum temperature is 650 degrees for compression. Take Cp is equals to 1.05005 kg per kilojoules per Kelvin. Y is equals to 1.4 compression index. For combustion, Cp is equals to 1.15 kilojoules per kg per Kelvin. Combustion index is 1.13. First of all, the first thing you need to do is to draw the TS diagrams. Then you are supposed to represent how the gas turbine looks. Then we have this is the combustion chamber. We have the HP high power turbine, and then we have the low pressure turbine. We also have the power shaft that we are told that the compressor drives this is the compressor driving the high power turbine, which in turn is driven by the HP which is driven by a power shaft. Combustion chamber, which is this one, we're going to take note of T1, T2 and T prime, T2, T3, T prime, T4, T prime, T5, T prime. And this is the isentropic diagram. See, pressure, temperature rises from 1 to 2, but temperature in 2 prime is slightly higher than pressure 2. We get 3, that's the highest temperature. Then temperature starts to drop until we reach 5 prime. Now we're going to solve the problem. To find T2 prime, get that T2 over T1 is equals to P2 over P1 Y minus 1 over Y. T2 is equals to 290. We have already changed the T1 into Kelvin, which is 290 times 8, the compression ratio, times the expansion index, which is 0.4 over 1.5. You get T2 is 525 Kelvin. To get T2 prime, which is slightly higher than T2, it is T2 prime minus T1, T2 minus T1. After evaluating this question, you get that T2 is equals to 584 Kelvin. Work input in the compressor is equals to work input in the low pressure turbine. work input in compressor is getting by Cp T2 prime minus T1 is equals to Cp times 294. After evaluating T2 minus T1, you get 294, which you get that it's 295 per kilojoules per kg per Kelvin. To get, you remember that T3 is the temperature at the highest pressure, which was 650. After converting it, you get it is 923 Kelvin. Then you're supposed to evaluate work output at the high pressure turbine, which is T3 minus T4. You equate it to the work input in the compressor. Get that T4, you get that temperature of T4 is equals to 257 Kelvin. T4 is equals to 923 minus 257, which is 666 Kelvin. To get T4 prime, which is isentropic efficiency of HP, is equals to T3 minus T4 over T3 minus T4 is equals to 0.8. After evaluating this, you get that T4 prime is 620.5 Kelvin. Then we move to getting the temperature at the low pressure turbine, and this is how you evaluate it. After evaluating this whole question, get that it's 1.6 bars. So pressure and temperature at the low pressure turbine is 1.6 bar, and the temperature is 393 degrees centigrade. After changing this 666 Kelvin into degrees. To find power output, you must evaluate T5. After evaluating T5, you get that T5 is 588 Kelvin. Isentropic deficiency of low pressure turbine is equals to T4 minus T5. T4 minus T5. Note that this is T4 prime. You get that is equals to, so work output of the low pressure turbine, you get that it's 774.5 kg per kilojoules per kg per Kelvin. Closely follow the procedure so that you get these things correctly. As you are going to finish up, net output is net work output is the work done by the low pressure turbine times mass flow rate, which was 1. Get that it's 74.5 kilowatts. Work ratio goes to net output over gross work output. So net output was 74.5 kilowatts, but the gross work output was the work output of the low pressure turbine and the high pressure turbine. After evaluating, get that the work ratio is 0.201. Heat supplied is compression index T3 minus 2 T2 prime, which you get is 390 kg per 390 kilojoules per kg per Kelvin. Looking at the TS diagram, this is the heat supplied. Heat supplied is from T2 prime to from the 3 to T2 prime. This is the heat supplied. Note that that's how we get the heat supplied. Then after evaluating, get that 390 kilojoules per kg per Kelvin. So thermal efficiency is equals to net work output over heat supplied. After evaluating, get that thermal efficiency is 19.1%. I hope you have understood. Take note to subscribe to the channel and hit the notification bell for any new videos that are informative like this.